So we're working on the worksheet here, and I'm going to show you how we're going to go about a little reviewing. First off, this is the page from my Honda CR-V, and remember, bore is the size of the piston, and stroke is how far up and down it goes. And so you could draw a cylinder for that size, and we want it in centimeters, so it's 8.7 centimeters all the way across the piston, and it goes up and down. Oops, I covered up my number, didn't I? 9.9 centimeters. So if we take our calculator and multiply, oops, I'm going to use this calculator, and multiply, it's 8.7, but it's half of that. So 8.7 divided by 2, because remember that's the radius, and so we get 4.35. So if we square and multiply that by pi, and multiply that by 9.9, we get the size of one piston. Since it's 4 pistons, we're going to multiply that by 4, and we find it's 2.4 liters, which if you look at the sheet here, I have 4.7 liters. Is that what we said? Oh, I'm sorry, I was on the truck engine. 2.4 liters for the Honda engine. Let's do the same thing with the truck. So this time it's going to be, you got a little shadow there. Let's redo that. So it's going to be this time, oh, you have to know that we are on the 8-cylinder engine. I have a V8, so we're going to use the 2UZ. So our engine size is 9.4 is across, and the stroke is 8.4. If you notice, it's not quite as big across, and so I'm sorry, it's not quite as much stroke in the truck engine, so it doesn't move up and down as much. It's got a lower compression ratio than the Honda had. If you notice the compression ratio here, it doesn't say what it is, but the compression ratio on the Honda was like 9, which is a pretty high compression ratio. Okay, so we take 9.4 divided by 2, and we get 4.7. So 4.7 squared times pi times height, which is 8.4, and then we have to multiply that by 8 because there's 8 cylinders, and we get 4.7, which if you look at my pickup here, it's a 4.7 liter engine. But that's not the one that we're working on today. What we're working on today is finding out how revolutions relate to engines. The first thing you'll notice is that our engine size is, our wheel size is 22 inches from the left, 22.5 inches from the left, and 6 inches from the right, makes 28.5 inches. You'll also notice that in 5th gear, we've got a transmission ratio of 0.566, and then the final drive ratio is 4.5. So here's where we start. We're starting at 2200 RPMs, and we want to figure out how many miles per hour that is. So let's go through the form here of our equation and get how fast things are going. I've got the equation copied down here, so all we need to do is to use this formula and we should be able to figure out our answer. Okay, here we go. Alright, we had 2,300, well, let's say 2,100 RPMs, 2,100 RPMs, and then one revolution of the drive was 0.566 revolutions of the engine. One revolution of the drive was 4.5 revolutions of the drive was one revolution of the wheel. One revolution of the wheel was 28.5 pi inches. 1 hour is 60 minutes. 1 foot is 12 inches. And 1 mile is 5,280 feet. So on our calculator equation, we'll use the fraction key. 2,100 times, what other numbers are on the top? 28.5. Oops. Times pi times 60. Those are the numbers that are on top. In the denominator is 0.566 and 4.5 and 12 and 5,280. So when we press that, we come up with a miles of 69.9 miles per hour, which if you look at my screen here, it does appear that I was driving somewhere around that speed, around 69, 70 miles per hour. Okay, next one. You have to figure out the speed that the Tundra is going using the exact same information. Notice here the wheel size is a little bit different for the Tundra, not that much different. It's actually about 30 and 7/8 inches, and the transmission, what you want to pay attention to is that it's the 4-speed automatic, but it's the larger engine. So we were in 4th gear, which would be 0.705, and the differential ratio is 3.916. I did not have it in 4-wheel drive, I had it in 2-wheel drive. And then the transfer case was 1 to 2.566. So make sure that you put those numbers in and see if you can figure out what the speed limit or how fast I was going on the left-hand side.